So, welcome everyone. I'm going to present attacking and defend Kubernetes cluster with KubeHound, an attack graph model. For first, I wanted to thank Troopers for having me here. It's really an honor to be on this conference. And since I'm going to speak for about an hour, I'm going to introduce myself pretty quickly. I used to be a pen tester, and then I switched to the engineering side as developing side, but really with really interested in offensive security. So if you didn't notice, I'm French. I'm already apologize for that, but we will go try to on that later. So this project is not my own project; it's a team effort. Actually the lead tech on this project was Jeremy Fox, who has left the company since. So this is why he's no longer with me today. He's now a staff engineer at Oracle and also had a lot of background into offensive security. Also, Edward, I will not say the last name because even though I'm still working with him, I can't manage to actually say it. So we just call him Edward, was also part of the project and the team in Datadog. So here's the agenda, seems pretty long, but don't worry, we try to go pretty quickly over everything. So first is I need to do some introduction. I wanted to know who is aware of Kubernetes stuff, like who is playing with it from offensive or defensive side. Okay. So I'm just going to go over some pretty basic stuff, but that you actually need to understand before continuing. So first, what is Kubernetes? So Kubernetes is an open source platform where we actually managed to have some containers application being shipped, and it allows you to have scaling capabilities and high availability. Then you have container, and container is the smallest unit that we will actually be part of the Kubernetes model. It is actually able to ship sandboxed application, but here sandboxed is not the way we intended. It's not really for security, but it's for a developing point of view. So it allows you to ship an application that if it is working on your laptop, it will also work on the Kubernetes, but sandboxed was not made actually for security purposes, and we will go on that a little bit later. Then you have pod, which is like a deployment unit into the Kubernetes world. So basically it can contain one or more container, and it's being designed to run stuff basically on this Kubernetes platform. And last, you have the node, and the node is the closest thing you can have to a real machine. It's where you can actually parameterize CPU, memory, and stuff like that. And when you group all the nodes together, you actually get a cluster. So to get the picture, you go to the container. On the container, you got the pod. On the pod, you got the worker, and everything together. It's a cluster, a Kubernetes cluster with a K8s API. Basically, it's where you can ask for information about your cluster. And you have also the cloud provider, but this will not be part of the talk. We will only focus on the Kubernetes environment itself. So again, who is more on the who has done some offensive work on Kubernetes? Okay, so some of you. So again, it's just to have the basics. So first, it's container escape, and container escape. The goal is actually get from a container and usually escape to a node. It's basically try to break your boundary and try to access to other type of information that you will not supposed to. And usually it's through misconfiguration. You have after Kubernetes identity, so everything that is actually being run into a cluster is attached to an identity, usually service accounts that are linked to the container which is being run under. And you have attached to that roles, and roles actually allow you to get some resources from the API, and of course some of the resources have obvious security issue, if you can release the secrets, that's going to be an issue, or if you can execute some pod and so on. And last, in the model, you have volumes, and usually volumes can be a way to actually make a bridge between container and nodes, and this is why we put it also as something we really want to emphasize because it's really important into the model. So again, you have the container, so the container you can escape to the node, you can do some privilegiation through the wall, and so on, and that's really what we want to try to tackle with KubeHound. So, of course, there are a lot of other attacks, but we not have time to cover all of them, and that's not the goal of this presentation. But that's really just to give you the 101 basic out of it. So, the problem in space. So first, let's say you have two vulnerability, and two are container escape. And the first one is actually a public-facing container, which has, should not have this kind of right. So here he has like the privilege true being activated into the container configuration. And on the other hand, you have another container escape, which is in the control plane, DNS container, and it has the cat-sys module capabilities. And both are container escape, so both usually are, the same in terms of criticality because they allow you to escape from it. But one is not public facing, the other one is like has restricted access, like a lot of audited in place. But to get this context out of it, you have to do some manual processing. So if I ask you to do that on a 1,000 container escape, well, that's going to take you a lot of time to process each one of them and try to figure out what is it. So let's say we have a cluster where we have like 14 container escape, a lot of privilege escalation, and a lot of vulnerabilities into it. And I'm going to ask you, how secure is it? Well, you can't tell me because basically you don't have the context about it. So is a node adage that was actually said by John Lambert a long time ago. It's like defender synced in list and attacker synced in graph, and as long as this is true, attacker win. And that's basically what we did. And we took him to the ladder and try to be able to get this graph thinking to get a security posture that can actually give you like some value KPIs really for free at scale. So the goal is really to shift from a list approach, so like we were saying, how many vulnerabilities, CVE, and stuff like that, and get to the newer graph approach where you can actually get some concrete information out of it that will make a lot more sense than the traditional way. And basically what we want to do by having the security posture is basically try to have it for the current state. But if we have it for the current state, we can also measure, changing over time. So if we know how many, percentage of internet-facing stuff that are actually being exploitable, we can measure it over time if you can do it at, at one specific time. So at Datadog, we have a lot. We are really a Kubernetes company. I used to do consulting before, and I never encountered anything as big as, Datadog ecosystem. So it's like really big, and traditional pen test is not enough. You can really scale. You can really have this value out of it. So I will try to show you pretty quickly how we can actually get. So it will not be against Datadog, of course, but I will try to a quick demo on the tool. So just pray with me because that's his live demo. So everything can go wrong here. So first, I'm gonna actually deploy a later cluster on my laptop to do the testing. Like I was saying, I don't want to do on the real world environment. So I will go on that a little bit later. Here it's scan cluster, and that's basically allow me to spin up a small cluster on my laptop with vulnerable configuration. And when it's being done, I'm going to ingest it into KubeHound and then show you some basic KPIs that are being processed automatically. So yeah, I just need to fill the time here. There we go. So just for the sake of I could have spin it before, but I'd really you guys to have the real live demo experience. So here it is. Now I'm just gonna run KubeHound. It's gonna spin up everything it needs. So we are, of course, then is Docker stuff that needs to be run. That are actually gonna get spin up by KubeHound. So again here, live demo, so it takes about 40 seconds, 50 seconds maybe, to get spin up. And once we have that, I will run a small Python script that would actually create a dashboard with the basic metrics that I just talked about. let me drink a bit. Come on. Here we go. So I'm asking, do I want to dump this? I say yes. So I'm sorry, I don't know if you guys can actually really read back then, but TV is what it is. And now I'm just gonna run my small Python script. So this is like more of a POC than the actual application itself. It's just to really emphasize and show how it can be done. It's really something sketchy right now. We try maybe to bundle it into like a more formal application later. It's more to show you the capabilities and what you can actually do, and how easy actually to get or retrieve the KPIs that you actually want and that actually matters to you. So here I'm got like some global KPIs, some KPIs about endpoints, volumes are going to be identities and containers. So the last one is identities. Here we go. Should be pretty. So everything is working so far. So here we go. So this works. So now just gonna. So here we have like the. So yeah, I had to make it big, otherwise the folks on the back can read it. So I'm sorry, it doesn't fit in the screen. But so you have like all the different attacks that you have into your container. So you got some global statistic. So half of the assets are actually vulnerable to critical paths, which is bad. Like 100% of my endpoints are actually can lead to complete takeover of the cluster, which is bad. But again, it is like that's what we intended here. Same for containers. Half of them can actually be compromised, identities, and so on. And you also get the list of everything that is actually like linked to the vulnerable attacks. So this worked. Thanks for praying with me. And let's get back to the slide. So here we go. Of course, I'm going to talk a little bit like how did this magic happen. So I'm going to talk about graph theory. So that's, well, it's not going to be about financial advice, but about like the study of mathematical stuff. And basically, again, here I'm just going to go over of like taxonomy 101. So we all speak the same language. So first, we have a graph. Obvious, it's like the complex representation of what we want to output. Then we got vertices, and vertices can also be called as node, but for obvious reason, I will try to avoid it because after you will not see the difference between a Kubernetes node and a node from a graph theory, so I will call it vertices and not node. You have edges, so basically edges is where you link one vertices to another, and when you have like several vertices being linked by several edges, it's what you call the path. So if we output it here, it's like you got vertices one linked to another one by an edge, and you get like a full path when you link more of them together. So why KubeHound? First, it's really the goal is like having these visualization capabilities and graph technologies into the apply to the Kubernetes world. And when we did the research, there were no actually. So we started like maybe a year ago, a little bit more now. And there were no tool existing except, well, I will not introduce it here, I guess, but the Blauman one, we really think like make a game changing into the Windows security world. And we say, why not just reapplied that basically, was applied to Active Directories world. So in our world, in Kubernetes world, you got entity. So basically an entity is like an abstract representation of a Kubernetes object. So usually when you got a container, we call it container, but sometimes we had to, add our custom entity. So permission set is one of them. It doesn't exist into the Kubernetes world, but we made it as an abstraction on role and role binding for engineering reason. I will come to that a little bit later. You got critical assets, and critical assets is really important in our model. It's basically the end goal where we try to create the graph. It's say, when you reach a critical asset, we end the graph. It's like, okay, it's done, it's game over. It's like be domain admin, but it's more cluster admin that is in our interest. And basically it's like a path that leads to this critical asset. That's what we call a critical path. So you can start from an entity, so it's an endpoint, and end up to cluster admin, and there you have your critical path. And attacks, it's what we call edges, and it's what's being linked from an entity to another one. So every time we link two entities together, they are basically linked by an attack. So again, if we take the same model, we got endpoint that is linked to container, and if you link like from the endpoint to the permission set, you got this critical path. So if you read it as an offensive guy, you can see that actually endpoint is being exposed by a container. From this container, you can actually use the right by the service account to assume an identity, as its identity can actually lead to cluster admin because it has like its own permission being cluster admin. So that's pretty simple, of course, and the goal is really try to get like more completed one. So, you know, in a nutshell, basically this attack graph model, it's really try to represent all the hops and everything that is being graphed together. But what is really important, it's we try, if there is a link between one object to another, it will not get missed by KubeHound. If it get linked, if there is some link, there is the graph actually is going to get computed, and you will be able to get this path from point A to point B. That's really important. As right now, it's working as a snapshot. So as you saw, I have to retrieve everything on like a specific time, and then do my analysis. It's not live. It has to be like an image of the Kubernetes cluster at a specific time. So again, just to explain that what I'll just run on my laptop. So you got KubeHound that actually asks the Kubernetes API to get all the resources. From it, we compute the attack path tool in database, and from there, we actually ingest the attack path into a graph model, and from it, you actually query the graph model to try to do the hunting and get what we want. So the goal, because you will see that a little bit later, it's sometimes what you get, because you will see that your cluster actually has a lot of attack paths. But the goal is really to get from this kind of a lot of stuff, kind of worms, to try to pinpoint the one that actually matters, and that's also what we want to do. KubeHound to achieve is really having this ability to actually pinpoint where the real security, the real problem are, and what you want to tackle. So, like I showed you earlier, was like a dashboard. It's not really like the way we use it like if you want to do like manual stuff. So we are using the Gremlin language. So who knows Gremlin here? Ooh, actually, so I might need to talk to you guys after, because to be honest, first time I said, oh yeah, it's looked pretty easy, it's pretty cool. But after a month, you were like, it's like I will never like manage to get it work. It's like, so it was really, really hard. So we managed to understand most of it, but we still have difficulties around it. So we decided to develop our own domain-specific language to have a learning experience that is not as hard as just learning Gremlin, because trust me, it is hard. So the goal is to have like those huge Gremlin requests that are actually really complicated to get something really easy that actually can be a lot more obvious to you. So for instance, you just say, okay, I want the pods. From all the pods, I want the critical path. And I just want to get like the first 100 out of them, because for performance issue, I just want to scope to like limited. But try to read the one on the left. Well, good luck. So we documented everything on our website. So we have like a documentation of all the DSLs that you can actually use in the model. And we try to put like concrete examples so it can be easy for you to actually use. So the UI, that's a complicated topic, because in our team we just prefer backend stuff, and we are it's really hard to be front end. So we focus more of our energy on the backend stuff, and we just try to get like out of the box UI. So we first went with an application called g.v, but we went away for it because first it was free, now you have to pay. So it was against our mindset. We wanted to be everything being open source or at least free. It was really the oriented developers, and it was really hard to. It was like a rich client you had to install on your laptop. You couldn't ship it pretty easily. So we went to Jupyter notebooks. We actually are pretty cool. I just discovered it on the project. I never used it myself before, but it's really nice. You can share results, highly customizable, and there is like a plugin directly being available for Gremlin, which was pretty cool for us. So, like I just showed you earlier, you don't have to do anything, so it should be pretty easy to use. You just run KubeHound, and it will connect to your cluster you are currently being connected to, and we dump everything, ingest, and put it into the graph database, and that's it. There is no fancy command or anything. You download the binary from the GitHub, and that's it. So again, pray with me. Really hard, because that's, again, a live demo here. So I'm not going to tempt too much of the gods here. So I'm not going to re-ingest it. I'm just going to use like a special notebook I made for Troopers. So you saw the data have been ingested previously, so I just will not go over again. So I'm going to reuse the same data here. And we are going to try to go over, try to show you the capabilities of how Kubernetes can actually be useful. So first, I'm just going to, kh.v actually just print out all of my cluster. It's just to show you. So let me 1 second, because here we go. Let's gain some space. Here we go. So that's our cluster. So that's represent all the vertices in the cluster. So the blue dots, I think, is the endpoint. Each color has its own type. So that's a pretty small cluster. Let's face it, we have like 300 something entities here. So I'm going to ask to get all the critical paths from anything, basically, and limit it to the 500. And that's where the problems begin, because actually what you get is this. So it's not really readable. It's really hard, like, where do I start? Just too many stuff, so it's not really human. It's hard to process from a human point of view. So, okay, maybe asking from anything is not that great, so let's start with containers, because, usually we are interested in containers where the application actually are and where the VNP actually leads to. So I'm going to ask again here. I'm limiting 5,000 for like the demo effect, but also you will see that even doing it on like container, we still have way too many stuff, and it's hard to really know where to begin. So you're like, okay, a container is not, but let's start with endpoints, because endpoints is actually what's facing, cluster from a user point of view. It's where an attacker is likely to, try to compromise it. So you do KH, that endpoints are critical paths. So again, here it's like all our DSL, because we think it's like a lot easier to process and to do like the crazy other queries. So here we go. I guess not everyone pray in the room. Here we go. So let me reload it. Nope. There we go. There we go. So endpoints was here. That's sad. What? Yeah, that's true. Yeah. Yeah, sometimes, but shouldn't be like too many. So let's add like a limit here. So that's whoa. That's demo effect. Restart. Here we go. So is it back on? Okay. And here we go. Sorry. So we got like endpoints from a critical path. So well, that's not endpoints, is it? Yeah, it's because there's a limit. That's shitty. Yeah, my colleagues advised me to do a video. I was like, that's fine. I've done it before. Maybe I should have listened to them. So, come on. You have to be. No, I don't want to do that. No, I don't want to rerun all. Shut down. Restart. There we go. So I guess that's going to be a good introduction. It's because also we introduced, because sometimes running on the laptop has, its own difficulties, as we can see that for, even we have good laptop in Datadog, sometimes, it's not enough. So yeah, that's not too bad. So from the endpoints, I want to try to, actually, let's do some limit here. Okay, I'm gonna try to, I don't have that many. I don't have the one that actually, 10,000, 20,000. Here we go. So, you will see that it's gonna be a little more. So here it's like, I limited to 20,000. Let's push the lock to 30,000. And here I'm trying to figure out like which of my endpoints are actually, here we go, I got the result I wanted. And it's printing out like all the services that actually are vulnerable to critical path. So like, I guess most of you here are like actually saying, that's looky yummy, I got like GMX endpoints. That looks cool. And we have on the other one, kubeDNS that I talked on the introduction on case that we don't really care about because, we know that it is actually not really a security issue because it has to have this like right into it. So I'm gonna try to put them aside and I'm gonna try to ask to get all the critical paths, or maybe I should add some limit back here. Again, and try to add and see a specific focus for all the endpoint except the kubeDNS one. And here we go. You know what? Let me just back in down. Here we go. And now we come to that a little bit later. So, didn't pray enough. We come to that a little bit later if we have time to try to finish the demo. As a demo god, that's definitely against me. So, how this? I don't know if that's magic anymore, but what's happened under the hood? So. The architecture here is pretty easy. We have a collector that actually, try to retrieve all the information from the K8s API. We got an ingester where it actually parallelize and ingest everything into the database, and we got the builders that actually build the graphs that, what we are interested in. So how it's being processed? So you got, you can recognize here a Helm chart. got like pushed into our Mongo database, and from there we just like translate it into a Genus graph information. So from an architecture point of view, collector again, pushing to a builder that actually push the graph, and from it you can actually visualize with the Jupyter directly. So, well, it's pretty simple architecture. So again, ingester, collector, builder, and then visualization. So the collector, we try to make it safe because we don't want to break your cluster, because we can hammer the creates API. So we try to limit, and we got like all the specific limitations. So we limit it by default to 100 requests per second. The size of the different stuff we try to retrieve is by default. And you can actually configure any of that if you want to test your luck and bump it and make it faster. But that's really where you'll also see, like in the demonstration, having everything on a rich client sometimes can have a limitation. Also, it doesn't scale well. So this is why we try to introduce CAS. Of course, Kubernetes as a service. So I don't know if there is like, if she's a big star in Germany, but so how can you use KubeHound at scale? So one what you need to change was actually to handle all the airbag stuff, which can be a pain. We need the collector to actually try to get the right resources, and from that you need to have a way to handle all those airbag issues. Then it has to be easy to deploy, because like if you have like hundreds of clusters you want to cover, you need to be something that can be shippable pretty easily. And then it has to be also scalable, because like I said, if you have like unlimited cluster, you need to be able to handle all of them. So of course we make it to the challenge. So that's basically what we wanted to put. So we have like all the cluster on the left. So let's say you have 3 clusters: production, staging, and dev. So we put the collectors directly that will actually get the information. Then we push it to like a data storage. So it can be S3 bucket or whatever cloud provider that you are using to push it to somewhere. Then it's going to actually push a signal to the Kubernetes, to the KubeHound ingester, which through a gRPC signal that will actually retrieve the data. And from it, we will actually like create and push the data into the MongoDB and the Genus Graph one. And then you can like visualize it through the Jupyter one. And that's what we call like as a service, having this capacity to actually split between the collector, the ingestion, and everything. And also allow you to have like a big Genus Graph instance where you don't have such limitation as we had when you try to make like queries that are actually too big for your laptop. So in a nutshell, what is it? Kubernetes as a service is like distributed. It's a distributed collector. It's a centralized ingestion. It's like a unified source information where you can actually get all the information that you actually need about the security posture of your cluster. So some metrics in data log. So that's my laptop, but what we use is more of a like 60 gigs RAM just for Genus Graph, which makes the query go a lot faster. So we don't have actually issue. Like a lot of CPU, but the size of everything that we collect is actually not that big. It's about like 10 gigabytes per day. So for all the cluster, and the average time of like ingestion to really rehydrate. When we get the dump and push it back to the Genus Graph, it's about 1 minute, which is like pretty short. So, but what if, I guess there is also a lot of security consultant here that don't have this really problematic. So how this Kubernetes as a service can actually help. So we try also to make it available for people from like a consulting point of view. So you can actually do the dump offline. Like I can just do like KubeHound dump, and we'll put like we'll spin up everything and do the dump actually locally, and then you can re-ingest it directly on your instance, in your office or on your laptop, or you can just use something pre-built. We just like try to split everything so you can use it the way you want to. Also, we try to make it also a good thing, a good tool for consulting people. So another part I wanted to talk about is like the research and development process that we made on the tool. And why we wanted to talk about it is basically we think it can be actually applied to other stuff like HashiCorp Vault, AWS IAM or stuff like that, because we believe that the graph technology can actually be a good thing to implement into other security problems that need to be solved. So first, you need to research like everything there is about Kubernetes security, because all that attacks that we implemented into the tool were not found by us. It's like public knowledge, basically. It's everything. But you had to do like those, regroup everything and first understand so you can actually know what to build. Then, when you get everything, you need to like sketch out the design, what vertices you need, what properties you need, and stuff like that. And then, of course, port it to a graph database. So, first, like main topic we try to tackle was airbag stuff, because who doesn't love airbag? It's always easy stuff, of course. Not really. It's always a nightmare, especially in a Kubernetes environment. So we had to read a lot of blogs, read a lot of official documentation, a YouTube channel and stuff like that. So for instance, the compromising Kubernetes cluster by CyberArk was really a good stuff, where we actually try to understand what actually was made. So that's like a first sketch of what we have done. So you see here, we try to, so at this stage, there was nothing being designed. So we wanted to say, okay, we need secret, we need roles, we need identity, which properties you need. So we need resource, we need verbs, all those kind of stuff. And basically, we try to do that to every single attacks. And then we put it like as a Neo4j for the first POC of the tool. And that's basically how it looks. So we try also sometimes to push it a little bit further than what was available out there. So for instance, it's like about the role binding attacks. So we made, I know the guys on the back can read it, sorry. But basically you can find everything online. And we try to push all the research that was made on our website. So also, once you have the attack, you want to do it yourself. And one way we found it was the client cluster, which was like I showed, it allows you to actually spin up your own Kubernetes cluster on your laptop. And it is actually easy to set up, and it is so easy that you can actually automate some end-to-end testing. And that was really valuable for us because as I will describe it a little bit later, we use it as like a regression model for our tool. You have to keep in mind that client cluster have some limitation because it's like sharing a kernel. So for some vulnerability, like the EMH core pattern stuff, it will not work, especially if you are on a Mac, because the kernel is not really shared, and it implies that there is some limitation. But for most of them, you are perfectly fine by testing or doing all your testing into this simulated cluster. So, like I said, everything has been referenced on our website. So we made the prerequisites, the exploitation step by step, the checks that you actually need to do to see if there is a vulnerability. And we also try to push the defense or the mitigation against all of them. So I really invite you, if you are interested into it, to go over. We listed over 26 attacks for now, and everything is being described, and we really want it to be as practical as possible. So those attacks, sometimes it's not that long, but it's like really what matters. And this is why we try to back everything that is being implemented into the tool. It's actually backed by the research being described on our website on kubehound.io. So like I was saying, that's really cool to make all of this, but how can you make sure you don't actually break stuff when you try to add new feature? So first, we try to make like unit tests, because that's really popular into the engineering world, but not that much into offensive security world, because usually, well, we don't have time to do so, especially when you're a consultant. So we try to push, unit testing to make sure that we don't introduce, regression, the code actually doesn't break stuff. But it's not enough, and this is why we try to introduce system tests. And basically, every time we push a PR, we spin up like a vulnerability account cluster on GitHub Action. we translate the configuration from this cluster into Golang code, so we can actually match, okay, do I have all the pods, do I have all the nodes actually in the end results? We automate the ingestion, so we build the application, run the ingestion, and then compare, do we get this attack? Yes, we still have it. Does the DSL still work? Yes, it does, and so on. And this gives us confidence that every time we add new feature, so actually the models that we put in place is actually still working. So I know I've been talking for a long time, so I guess it's time for a fun fact. I call it when the CTO joins the party. So actually, at first, we made our first POC of the application. It was Neo4j base. It was pretty long. It took like more than 10 hours to ingest pods, 1 hour to dump everything because we are using like the dirtiest bash script you can think of. And we push it, as like we wanted to shift. And okay, now let's be full open source. Let's say we have like 1 hour to ingest everything. It seems pretty fair to us. Like 10 minutes to retrieve all the objects from the API. And that was the goal that we set up to ourselves. And we're happy. We made it. It's, we released it, we were happy, and we say, okay, next quarter, what we are gonna do, and we are gonna try to, put it as a service. So in Datadog, we have, what we call OKR. So I don't know if like every one of you is aware of OKR, but you try to describe what you are gonna do the next quarter. And it's like a small document, like maybe a 1 paragraph where you try to emphasize what you are gonna do. And you got the CTO who doesn't have a clue of what is KubeHound, because it's like a CTO of a 5,000 tech companies that has a lot of other projects. And he's saying, wait, guys, I mean, you are saying it's taking 1 hour, but if I do like some napkin computation, it's should be a matter of seconds and not hours or days. Like, what's going on? And you get like this comment, so you're like, oh, that doesn't look good. So we try to do everything. So of course you never say no, because usually when those guys kind of do some comment here, they know what they're talking about. So we put like memory graph, tune the queries about it. We optimize how we generate the edges. We optimize the query APIs call, because there is some tricks you can actually gain a lot of time. And we actually went from like 35 minutes to 30 seconds. So you have these guys with like CTO, like read like in 10 minutes your paragraph, and pinpoint say, oh, you are doing something wrong, and you're like, oh. And you've been working on the project for like several quarters. But I guess this is why he's CTO, and this is why I'm just like building the project. So, but that was like a really good comment, and that managed us to actually improve a lot the performance around it. So the key takeaway I would have, it's like we really think that power of automated graph is really the next thing for offensive security, and we really think it's like the natural evolution of the security tooling. And we think there's going to be a lot of more of different projects around it that will actually be really useful as for offensive, but also for defender, because it's allow you to get like this big vision pretty easily. So what's next? First, we want to be able to tailor you to your own environment, because we know you can have your own specific. So we define critical asset the way you maybe have different aspects of what is a critical asset, and we want to give you a way to actually be able to customize it in an easy way, so you don't have to change the code of what is a critical asset. So also, if you want to discard stuff from your graph and stuff like that, basically we really want to enable you guys to be in control, to tune the model to your own environment. We also want to, it's also something really important to our eyes, we want to put weight on the edges, because we know that all attacks are not equal. Some are really easy, some can be hard, some can, take time, so, do a lot of noise, and we want to be able also to, put in front the attacks that actually matter the most from an offensive point of view, and we think that, weight can actually be a good way to differentiate all the different attacks. KPIs, leadership loves KPIs, so we want to give you, especially for defense team, we want to put you like KPIs for free, so you can actually say, hey, my cluster is going better, but like those KPI actually matters, and are not some just how many CVE I got in my cluster, like real KPIs that actually make sense. So a lot of stuff. We also want to have our own UI someday, be able to do some diff checking, CI/CD integration. A lot of different stuff. We had like a lot of other stuff in our backlog, but we are a small team, and also hard to keep up with all the. We have more ideas that actually manpower to cover them. So let me just, if I have a few seconds, I think I do. So let me, still have 5 minutes. So let me do just one last ingestion. Here we go. Almost. Yes. Dumping it. It's done. Yeah, no, you're not happy. Leave. Guess what is the password? No, it's admin. It's a really strong one. There we go, troopers. Yay. So let's do the initialization phase, and let's go back where we were. So we were saying endpoints. Here we go, critical path. What is this word? Still not, isn't it? That's a pity. Yeah, Docker down seems to me. Yeah, well. Oh, here we go. Huh. No, we don't. Oh yeah, we do. Oh, wonderful. So you have like this. So I don't. Yeah, it's definitely laggy. So from here, touching. Okay, so here we go. It's just so big. So you got all this, but you can pin out that here you got the 3 endpoints that actually matters to us. So you see like the, GMX1. So we know GMX can be like always sketchy, and we get like everything is connecting to one container, and you got like escape to the node, and from there you got a lot of different stuff. But I guess what really matters is only this phase. So if we go back, and if you really want to pinpoint, all you need is actually like this specific stuff, and that that's actually what matters. So we went from the big chain of everything to actually one query that actually pinpoint like what actually matters into your cluster. So well, it was a break live demo, I would say. But so for instance, like I said, like with few queries, it's actually like enable you to pinpoint where the vulnerability are, and can actually say that you can actually see that all those 3 is like the weakest link on your whole cluster. If you want to spend a lot of your energy, this has to be where to focus. And I will go back to the presentation as it is. my last slide. So I will thank you all for listening to me. We are recruiting for the team, so if you are interested to be paid to, to develop on this project, don't hesitate to pick me. We are looking for a replacement for Jeremy, who left us. And thank you all again.
All right, thank you, Julien, for your contribution. Sadly, because we don't have much time and we need to set up the next talk, we don't have time for a Q&A session. If you have questions, I think you can feel free to approach him afterwards or in the coffee break or right now. But yeah, big shout out again for your contribution and thank you.